Hello, this video should be helping you with worksheet 4 from Math 3 Unit 1. Just to let you know that exponential functions is something that would be taught in Math 1. This particular year, some of you have students that never were in Math 1 or Advanced Math 8 because they came from Algebra 1 to Math 2. And so some of your students this year may have less experience with exponential functions than you will see in the future. And so this year this may require more instruction than future years when maybe it will be a reminder. But remember, everything Math 1 through Math 3 is not tested until their junior year of high school. And so this is a couple years ago and will show up on their state test. We are happy to have the opportunity to review this material. So the first thing I want to do is to just explore some graphs of exponential functions. I would do this with my students before I just started right on what's in the worksheet. And in old Algebra 2, our initiative materials, we plotted points to get the idea about the shape. And so as you plug in for the x, you get various values for the y. A good chance to remind them about a zero power and negative exponents. And so you get these points. And when you go to graph those, you find that at 3, you're all the way up here at 8. At 2, you're at 4. 1, 2, 3, 4. At 1, you're at 2. At 0, you're at 1. And then we start being very small, a half, a fourth, an eighth. It's nice to ask the students right now if there's a time when this graph is going to actually equal 0 or cross into the negatives. Is there some value that we could plug in for x that would turn this into a negative number? Is there some value that we could plug in for x that would make this 0? And it's nice for them to actually think about that and realize that no matter how small we make this get, we never will cross this x-axis, and this x-axis is in fact an asymptote. They learned that word in Math 1 if they were in that class. And every exponential function does have a horizontal asymptote that it approaches but never crosses or touches. And so this graph would look something like this. And that's basically how all exponential functions look. Sometimes they're steeper. If this number is a different number here, it might grow faster and so be steeper. And sometimes they even can go downhill, representing decay function. We will not have any of those during this chapter, so right now, just in the reviewing process, you might show them one to remind them of that, but all of ours will be with bases greater than 1, so they'll all be growth graphs as far as this goes. So here's the function, and if you went on to play with 3, I would recommend with your students that you go ahead and play with 3 also. 3 to the 0, 1. These should have been negatives, sorry. Otherwise I will not get those values. 1/3, 1/9. And they should still see that they are getting very, very low here, but they hit 1 and they hit 3. And then way up at 9. So this is the graph of 3 to the x. And notice it's a little bit steeper. I think of if this is a recliner, we've just sat our recliner up a little bit here. With this 3, it's going to grow more rapidly. And in general, there's 2 points you can think of for every exponential function. All of them, when you plug in 0 for x, you're going to get 1 because anything to the 0 power is 1. So you're always going to have a point 0, 1 on every exponential function that doesn't have any shifts involved, no matter what the base is. Another point that you can count on seeing is the point where you plug in 1. In this case, we got 1, 2. In this case, we got 1, 3. And in general, you will see that you're going to get, for any exponential, you're going to get, when you plug in 0, 1, and when you plug in 1, you'll get the base number, whatever that base number is. And just if you want to remind your students of what they learned in Math 1, we won't be using these, but if this base is bigger than 1, you're going to just kind of increase in this way. You might think about where the horizontal asymptote is in relationship to this 0, 1 point. It's just one below that 0, 1 point. You have a horizontal asymptote. In this case, our horizontal asymptote is at y equals 0. But in a lot of cases, it might move as we shift the graph, but it's always one below that 0, 1 point. So what I want to do now is look at your worksheet 4 and do a few problems so you can get the idea of teaching this with shifts, because what we don't want is for the kids to have to plot points on every one of these. They should be able to use what they know about shifts to get these graphs, make these graphs happen, and apply what they know. And so when I see a problem like this, I think of this as if f of x was 3 to the x, then the graph that they're asking me about is f of x plus 1. I just have a 1 added on the end there. And so I'm going to use the graph of 3 to the x and then do what I know about shifts and shift that up 1. So 3 to the x, not really the graph I'm after, but 3 to the x is just this graph. It has the point 0, 1 because they all do. I did this off to the side when I did this with my students, but on this first one I'll put it right on here so you can see. When I put in 1 into the 3 to the x, I will have 3 to the first, or 3, that b value, and I know that this graph has a horizontal asymptote at 0, and it goes like this. Okay. So plus 1 tells me I should shift up 1. So when I want to find this graph, I'm going to take this point and slide it up 1. I'm going to take this point and slide it up 1. I'm going to take my horizontal asymptote and slide it up 1. And so my new graph will just be like this. I didn't make a table of values and plot points. I capitalized on 2 points that I know are there all the time, 0, 1, and 1b, and I just shifted those points up. So the orange is actually my graph. I'll show you how I would do that if I didn't put the original right on this. So if I was going to do this one right here, number 2, I would just off to the side for myself think, what does the graph of 3 to the x look like? And I know it's going to go through 0, 1, and I know it's going to go through 1, 3, and it's going to have a horizontal asymptote. This is 3 to the x. So for this one, that didn't go down very well there. For this one, I want to go down 1, and so that means this 0, 1 will go down 1 to be on 0, 0. This 1, 3 will go down 1 to be at 1, 2, and my horizontal asymptote will be at -1. You don't need to draw that dotted line in if you don't want to, and it will go like this. The next point that I'm hitting is going to be 9 above my horizontal asymptote. 3 squared was 9, and then shifted down, so it should be up at 2, 8. And so that's off this graph, but as they do the project, they'll want to be that precise, so they'll want to make sure that they see where that's actually hitting. Good. Let's do one with something in here, because when I see this one, what I think of is if f of x was 2 to the x, then I have put something in where just the x usually would be. So this graph would be f of x minus 1. I put that into that spot where the x usually would be. So I'm going to go ahead and graph just my f of x. This will be this one, and that will have the point 0, 1. It will have the point 1, 2 because my base is 2, and that would be the graph if there was no shift. And now I know if I have a -1 in there that I'm actually going to shift a +1 that direction. So I will have moved over here. That means both of these points need to slide to the positive side by 1. So this 0, 1 will now be over here. This 1, 2 will move right here. And I still will not move up or down, so my horizontal asymptote is not going to change. It'll be just like this. If I wanted to, I could plot another point. 2, 4 would have been the next point, so that would just be over 1 also, and I can see how that's going to go. Okay, so that's how those go with shifts. Let's just do one more where there's 2 shifts together to give you the idea. We'll do number 5. On number 5, the parent graph that I'm working from is y equals 3 to the x. I know that that would be at 0, 1, and 1, 3, horizontal asymptote at the x-axis. And instead of 0, 1, I am going to, let's see, I'm going to move positive 4 and down 2. And so I'm going to go from that point over 1, 2, 3, 4, down 1, 2, and that will be my 0, 1 spot. And then my 1, 3 spot, I will go over 1, 2, 3, 4, and down 1, 2, and that will be my 1, 3. My horizontal asymptote was right at the x-axis, and it's going to go down to 1, 2 to be right here. And so my graph would look something like this. Missed that a little bit. So that's how you use the shifts to graph these. Your students should definitely not be making a table of values for every one of these problems. If they are, they're not learning the main goal of this unit, which is to use the shifts of functions, the reflections, the translations, to be able to make these graphs happen. So I encourage you to teach it that way, from the parent graph shift according to what they learned in the earlier chapters or earlier sections. Thanks so much and good luck.